guys, I am Vaishali Khan and we are discussing the digital circuits. Today in this video, we are going to have the in-depth analysis of the Access3 codes. So we are going to start today with the Access3 codes. We are going to see all of the properties related to the Access3 code, and then at last we are going to talk about the addition and subtraction of Access3 codes. So this video is going to be really interesting and informative one, and you have to watch it till the end to get a lot of information about the Access3 code. So now let's start our discussion about the Access3 code. When I was giving you the various types of codes, I told you Access3 code is an example of various types of codes, right? Access3 was the example of reflective code, the sequential code, and also it is the example of access k codes, right? So now what is the word access and 3 means? So whenever we have a BCD code, it is a modified BCD code. So how I'm going to modify the BCD? Whenever we have a BCD code, we are going to add 3 to BCD number, right? So I'm going to take a BCD code, I'm going to add 3. So what is 3? 3 is represented as 0011. If I have 0, I'm going to add 3 to it. If I have 1 in BCD, I'm going to add 3 to it. So in this manner, we are going to get the Access3 code, which means in every BCD, I have access of 3. Right, we can have any access k code. So if you want to make access 5 code, you can make. You have to add 5 to the BCD number, and in this manner you can make the access 5 code. So this is the very first property of the Access3 code, that it is a modified BCD code. Right, I'm going to take a BCD, I'm going to add 3 to the BCD, and I'm going to derive the Access3 code. It is a non-weighted code, which means at every location I'm not going to assign a positional weight. Positional weighting principle is not going to follow in any of the access k code, right? So again, Access3 is also a non-weighted code, and 0 is represented as 0 plus 3. So 0 is represented as 0000 plus 3 would be 0011. So 0000 plus 0011 would be 0011, right? Similarly, 1 is represented as 0001, and I'm going to add 3 to it. So here 1 plus 1 would be 0 with the carry 1. And here also 1 plus 1 would be 0 with the carry 1. 1 plus 0 would be 1 and 0. So now here 0, 1, 1, 0 is the code for 1. Similarly, I can get code for 2, which is 0, 1, 0, 1. Code for 3 is 0, 1, 1, 0. Code for 4 is 0, 1, 1, 1. Code for 5 is 1, 0, 0. Code for 6 is 1, 0, 0, 1. Code for 7 is 1, 0, 1, 0. That for 8 is 1011, and for 9 is 1100. So in this manner we can derive the Access3 code from the BCD code. Now the next type of code that we discussed was the sequential code, and I told you in the sequential code the next code word is changing only by the 1 bit. So in the sequential code, any code word obtained by adding 1 bit to the previous code word, and the same thing happens in the Access3 code as well. So it is also a sequential code. It is also self-complementing code. So it is also known as a reflective code, which means if I find out the 9's complement, I am going to get the 9's complement of the bit by reflecting 0 to 1 and 1 to 0, right? So what I'm going to do, I'm going to complement each bit, and I'm going to get the 9's complement number. So let's suppose I have 1. 1's 9 complement is 8. 1 is represented as 0, 1, 0, 0, whereas 8 is represented by complementing all 0 to 1 and 1 to 0. So 1, 0, 1, 1, right? So 1, 0, 1, 1 is the code for it. So this is how it can be represented as a reflective code. So now a question based upon this property: find the 9's complement of 592. So how the 5 is represented? So 592 in the decimal can be represented in the Access3 code by representing 5. 5 is 1000. Then what is 9? 1100. Then we have 2. 2 is 0101. So now what I have to do? I have to find out the 9's complement of 592. So 9's complement of 592 would be 407. So 407 now can be represented by just changing 1 to 0 and 0 to 1. Right, so this is the representation of 9's complement of the 592. Coming to the Access3 addition, and we will be having some examples based upon the Access3 addition as well. Now we have to do Access3 numbers using the simple binary addition first of all. right? After doing the binary addition, we are going to see the carry. If the carry is 1, we have to add 3 to the sum, and if the carry is 0, we have to subtract 3 from the sum, right? Coming to the excess 3 subtraction. So these are the various laws that you are going to follow while doing the arithmetic operations with the excess 3 numbers. So first of all, if I have the subtraction, we have a minus b. So first of all, I have to take the complement of the subtrahend. We have to take the complement of b, right, which is a negative number. Then we have to add the complemented subtrahend to the minuend, and now we have to observe the carry. If the carry is 1, then the result is positive, and then we have to again add the 3, 0, 0, 1, 1 and around the carry, right? Other than that, if the carry is 0, result is negative, subtract 3. So this is how we are going to do the addition and subtraction. Now one thing you must remember while doing any operation on the excess 3 number, we have 6 invalid state, and if these invalid states are coming, your answer is wrong. What are the invalid state? Invalid states are 0, 0, 0, 0, which is 0, because excess 3 code is any code added by 3. So when 0 is represented, 0 is represented by adding 3, which is 0, 0, 1, 1. Whereas 0, 0, 0, 0 is not a valid code, right? Similarly, 0, 0, 0, 1 and 0, 0, 1, 0, 0, 1 and 2 are not represented in excess 3 code. Then 1, 1, 0, 1, 1, 1, 1, 0 and 1, 1, 1, 1 are also not represented. So in this manner, we can find out that our computation is wrong or right. So now coming to the question, here we have to perform the excess 3 addition of 8 and 6. So now how 8 is represented? 8 is represented as 1, 0, 1, 1, right? This is my 8. Now 6 is represented as 1, 0, 0, 1. Right, now I have to add both of them. 1 plus 1 is 0 with 1 as the carry. 1 plus 1 is again 0 with 1 as the carry. 1 plus 0 would be 1. Now here 1 plus 1 would be 0, and we will be having 1 as the carry. So now if the carry is 1, we have to add 3 to the sum. So now we will be taking this 1 as 0001 and we have to add 3. So 3 is 0011. Here also it is 0011. Right, so now this is my add 3 operation. So 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 0 is 1, this is 0. So we have 0, 111 over here. 1 plus 1 is 0 with the carry 1. 1 plus 1 is 0 with the carry 1. So here we will be having 1. 0, 1, 0, 0. 0, 1, 0, 0 is representing my 1. And 0, 111. 0, 111 is representing my 4. So 8 plus 6 is 14, and from here also it is justified. Now second is the addition of 1 and 2. So 1 is represented as 0, 1, 0, 0. This is my representation of 1. Now 2 is represented as 0, 1, 0, 1. Now when I add both of them, I am going to get 1. That is 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 1 is 0 with the 1 as carry. 1 plus 0 is 1. So we are going to get 1, 0, 0, 1, but the carry is 0. So when the carry is 0, we have to subtract 3. Right, so we are going to subtract 3, which is 0, 0, 1, 1. So 1 minus 1 would be 0. Here we will be having 0 minus 1. So from here I am going to take the borrow 1 and I am going to subtract 1. So I am going to get 1 over here, and from here I am going to get 1, 0 minus 0, which is 1. Now here I am going to get 0. 0 minus 0 would be 0. So 0, 1, 1, 0 is a representation of 3. And we all know 1 plus 2 is 3. So now coming to the third question. So here we have to go to the perform excess 3 subtraction of 8 and 5 and 5 and 8. So 8 is represented as 1, 0, 1, 1, and 5 is represented as 1, 000. Right, so we have to do the normal subtraction. So for the normal subtraction, first of all, we have to complement the subtrahend. For complement the subtrahend, I am going to take 0, 111. Right, how we were subtracting, how we were taking the complement. For complementing, we were converting 1 to 0 and 0 to 1. So 5 is represented as 1, 000. So complement of 5 would be 0, 111. Now I have to add these two. This is my 5 complement. I have to 8 and 5 complements. So 1 plus 1 is 0 and the carry 1. 1 plus 1 is 0 and plus 1 is the 1 with carry 1. 1 plus 1 is 1, sorry, it is 0 with the carry 1. 1 plus 1 is 0 with the carry 1. So when the carry is 1, result is positive. And now again we have 0001 and we have to add 3 and around carry. So we have to add 3, so it is 0011 and this is my carry, right? So when I add 3, I'm going to get, sorry, 0 plus 1 is 1, 1 plus 1 is 0, and here I'm going to get the carry 1. 1 plus 0 would be 1, 0 plus 0 is 0, and this carry is added with over here. So I'm going to get 0, 1, 1, 0. So now 0, 1, 1, 0 is representing 3 and 8 minus 5 is 3, right? So now coming to the next subtraction, we have to do 5 minus 8. So 5 is represented as 1, 000, and we have to take the 8 complement. 8 is represented as 1011, its complement would be 0100. Now we have to add both of them. So when I add both of them, I'm going to get 1100. When I'm going to get the carry 0, so carry is 0 over here. When I have the carry 0, the result is negative, and now we have to subtract 3. So when I subtract 3, I'm going to get, so here I'm getting 1, 0, 0, 1, right? So now here we will be having 1, 0, 1, 0. I'm taking this borrow over here. So 1, 0 I have, and now again I will be taking the borrow over here, and here I will be left out with 1. 1 minus 1 would be 0, 1, 0 minus 1 would be 1, and 0 minus 0 would be 0, 1 minus 0 would be 1. So 1, 0, 0, 1 is representation of 6, but this is my complemented output. This is my negative output, so again I have to take the complement of it, which is 0110. So this is representing 0110 is representing 3, and because the result is in negative, so I am going to represent minus 3 as the answer. So I hope you understood the arithmetic operations and the various properties of the Access3 code and the Access3 code also in detail. If you have any doubt, you can put the doubt in the comment, and I will be trying to resolve your doubt as soon as possible. I hope you like this session. If you like it, please push the like button, subscribe to the channel, share it with your friends, and also give me your feedback. Thank you so much.